All right, I'm gonna have to try to figure out a way to cut this. Oh, hold on for a second. Got my wire. There we go. I'm gonna figure out a way how to cut this. But since no one is asking any questions, I'll just do some problems for a few minutes. See. If you have any problems that you would like to do, any questions that you have, this would be a great time to jump in and do it. But until then, well, big C. Until then, I'll just occupy myself doing this and figure out a way how to cut it. So anyway, they tell us that this is from the study guide or a version of the study guide. Right? Hold on, that's not right. I hope that's better. Okay. So it says that little a is 26, little b is 35, and little c is 11. All right. They want us to solve the triangle. So we're trying to find angle A, angle B, and angle C. From what you know, how do you think we find this? We are going to use the law of cosines. We cannot use the law of sines. We cannot use the law of sines because there's nothing there. So, we'll do c squared is equal to a. Yeah, I can see that. Yep. So a squared plus. Is this too small? I think y'all can see this. There we go. B squared minus AB cosine of big C. This is the law of cosines. Law of cosines. Whenever you have anything 2AB cosine C. Whenever you have anything, whenever you have all the sides, if it's not law of sines, it's law of cosines, basically. Okay, so we'll fill in what we're doing. So 11 squared is equal to 26 squared plus 35 squared minus 2, 26, 35 cosine of C. Probably should have my calculator out before I started it. All right. So this is 121 is equal to 676 plus 1225 minus 2 times 26 times 35, 1820 cosine of C. All right. These two I can just subtract, which is okay because I have a negative there. So 121 minus 676 minus 1225. Oops. Delete. So I have negative 1780 is equal to negative 1820 cosine of C divided by negative 1820 divided by negative 1820. And I end up with 0.978, so on and so forth, is equal to cosine of C. All right, from here, we're going to take the arc cosine of both sides. Because we're generally going to answer this in degrees, we want to make sure that our mode is in degrees because you don't want to do this in radians. So arc cosine of, I like to go back up and use the entire decimal that was given because I don't want any round off error. And I end up with 12 point, we'll say 03. Or did it say, let me make sure it said nearest. I want to make sure it didn't say nearest degree on me. Go away. There it is. Nearest 10th. So nearest 10th. So this is just 12 is equal to C. Little c. Now, good news, that was easy. Bad news, you have to do this for every single one. You know, so we got big C is equal to 12. Well, because it's a whole number, you could actually do the law of cosines here. I kind of like that better. I mean, law of sines better. Yeah. Sine of 12. Okay, let me stop. No, don't use law of sines. Because what I like to do, or one of the things I've learned in doing math is, if you do this wrong, and then you use this for your further calculations, everything's going to be wrong. So use what's given, which is these links here. Use what's given to solve your problem as much as possible. So no shortcuts for us. We're going to be doing this all by hand. A squared is equal to b squared plus c squared minus 2ab cosine of a. 2bc cosine of a. Yeah, I was trying to be lazy. That's my bad. Don't be lazy. So 26 squared is equal to 35 squared plus 11 squared minus 2. 11, 35, 11 cosine of a. Can we try two of every problem that will be on the test? If you have specific questions that you would like to ask, you can. But I'm not just going to randomly do problems. This is more of a ask questions. It's not a reteaching type deal. Okay, this is questions driven. I'm just doing this so that we can. So I wouldn't sit here on live looking. I actually want to be productive for us. You know what I'm saying? 676 is equal to. It's already up here. 1225, 121 minus 2 times 35 times 11. 770 cosine of a. Okay, so 676 minus 25 minus 121, I guess. So negative 670, yeah, is equal to negative 770 cosine of a divided by negative 770. Divided by negative 770. I'm actually going to leave this as a react. I'm going to leave this as a fraction because I like that better. 67 over 77 is equal to cosine of a. Right, so that means that a is equal to the arc cosine of 67 over 77. And that way, when you put in your calculator, you don't have to worry about round off error or anything like that. You can just leave it as a fraction, and then it'll do the work for you. So a is equal to 29.552, so it's just 5. So 29.5 degrees. That's A. This is big C. Why did I make it little? I knew what I was talking about. That's big C. So 12 degrees. A is, oh, you can't see this. A is 29.5 degrees. Now, once we get to this point, once you get two angles, you can find the third one. I would still like to check it to make sure, but you can find the third one. So you say 29.5 plus 12. So I suppose that B is going to be equal to 138.5 degrees. But we're going to check it and see. So B squared is equal to A squared plus C minus 2AC cosine of B. So that is 35 squared is equal to 26 squared plus 11 squared minus 226, 11 cosine of B. 25 is equal to 676 plus 121 minus 2, oops, times 26 times 11, 572 cosine of B. Go to 25 minus 676 minus 121, 428 is equal to 572 cosine of B. That was just a bit. It goes away over negative 572. Give me fractions. So this is negative 107 over 143 is equal to cosine of B. So B is equal to the arc cosine of negative 107 over 143 is equal to arc cosine of the answer. Boom. Well, actually, what we get is 138.4. So close enough. B is there, A is there, C is up there. So as you see, let's take the whole page. But it's not like it was hard. It just took a second. That's better. All right. So there we go with that. Do you have any questions, or am I just picking problems to do? Okay. I'll pick another one. Make sure we can see this all right. I know that there's a way to do this on my Surface, but I haven't figured it out yet. All right. So they say write the following as a radical expression. So this is number 3 on my study guide. So 13 raised to the 1/6 power. All right, this is the same thing as the 6th root of 13. I already know the answer to that. Okay. So raising something to a fraction is the same thing as the fraction, the bottom number, as the index of a root. That little number is called the index. All right. All right, next problem. Hold on. I think, I can pick some problems. Thanks. Oh, this is a graph. We can't do this one. Okay, here we go. This is a good one. Number 4 is a graph, and you guys see my messy desk. So, all right, 5. So we're doing m to the negative 2 over 4 m to the negative 6 raised to negative 2. All right. So what we want to do is, if we're simplifying this, you want to get rid of your negative exponents first if you can. So we'll leave the one outside to the end. So fraction bar, this 4 is on the bottom. We can not do anything with that guy. This m to the negative 6, this guy moves up and that guy moves down. So this becomes m to the 6 over m squared negative 2. It's going to make more sense to simplify this before you apply an external exponent. External exponent. So m to the 6 over m squared. There's a property. A, can y'all see that? Yeah, y'all can see it. A to the m over a to the n is equal to a raised to the m minus. Or in other words, if you have the same base or variable in an exponents, you subtract the exponents when it's one on top of the other. So this is 6 minus 2, 4, and it stays in the top. So this is m to the 4th over 4 to negative 2. All right. So this negative means I flip it. So this becomes 4 over m to the 4th squared. 4 squared is 16. M to the 4th squared is 2 times 4, which is 8. And there we go. All right. Let's keep going. Here we go. This is nice. That was like more algebra 2. This is more tricky. So, this is number 6 here for me. Cosine squared x minus 1 is equal to 0. And they want to solve this from 0 to 2 pi. This is standard, 0 to 2 pi. So basically, in one rotation, what is the answer to this? So knowing your algebra really helps here because you recognize this as a difference of squares. So this is cosine x plus 1, cosine x minus 1 is equal to 0. Two possible solutions. Actually put a line there. So cosine x minus plus 1 is equal to 0. That means that cosine, well, let me not skip steps. And you can't see because my hand is in the way. Subtract 1. Cosine x is equal to negative 1. Cosine x is only equal to negative 1 when x is equal to pi. That's one answer. Here, cosine x is equal to minus 1 is equal to 0. Cosine x is equal to 1. This only happens when x is equal to 0. So x here is equal to 0 and pi. One of the reasons that I like pre-calculus is that it takes all of the math that you've learned up to this point and it uses all of it. So everything is available for use. for this one. All right, let's try to get this lined up. Okay, we got another triangle. It would have been good if that paper wasn't curved on me. A, B, C, A, B, C. Okay, they tell us that little c is 16, A is 19, and big C is 40 degrees. We like this one. So this is 40 degrees. This is 16, and A is 19. We like this type of problem because we have a side and a corresponding side and angle. They're across from each other. We like that. So we know that sine of A over A is equal to sine of B over B is equal to sine of C over C. We don't have all of them, so we're going to start with A's. So sine of big A over little a. Well, we know what little a is. 19 is equal to sine of 40 degrees over 60. This is little a. This is big C. That's little c. All right. So we multiply both sides by 19 to get the 19 out of this denominator using some algebra here. So we end up with sine of big A is equal to 19 sine of 40 degrees over 16. Right. So that means that big A is equal to arc sine of 19 sine of 40 degrees over 16. Your calculator should be able to handle this, to be honest with you. Let's see. Arc sine of there it is. 19 sine of 40 degrees over 16. And I get round to the nearest. Carry your intermediate computations to at least 4 decimal places and run your answers to the nearest 10th. Okay. So in other words, this A becomes 49.7569. That's A. All right, which is 49 point, is it round to the nearest 10th? 8 degrees. So this is the one that we will use for our answer. This is the one we use if we do any more computations. Okay, and we do have another computation because we know A here. Can y'all see that? Yeah, I think here. 49.7597569 degrees. So now we can find B. Big B then is 40 plus 49.7569 minus 180 to B is equal to 90.2 or 2431, which is 90.2 degrees. And then we use log signs again to solve for big B. I mean little b. All right, so we'll do sine. Can y'all see that? Yeah. Sine of big B over little b. No, we're solving for little b. So we want little b to be in the numerator. So this is mathematically legal to do. B over sine of big B is equal to C over sine of big C. Don't know why I wrote the whole thing again, but whatever. All right, so little b over sine of 90.2431 is equal to 16 over sine of 40 degrees. All right, and the reason why we want our variable in the numerator is because we will just multiply both sides by that guy right there. Right, and you end up with little b equal to 16 sine of 90.2431 over sine of 40. Both of those degrees is equal to. So, oops, fraction. 16 sine of that over sine of 40. You end up with will be equal to 24.8914, but we don't have to worry about that right now. It's just 24.9. We solved the triangle. Again, not bad. Not bad. Let's see what else we got. Again, if you have any questions, anybody have any questions for me to answer before I move on to the next one? Do I have any problems where there may be a second triangle? I don't understand your question. Jay Jordan, I don't know if we have the same number 9. Is it about Chang flying the kites? I'm not being funny. It really says Chang is flying two kites. Oh, perfect. Let's do that one. Green and gray. If you could find one of those type of problems, let me know, and then we can do that. Yours says Scott is flying a kite. Okay, that's what it is. Not anyway. So since we since we don't know, since we both got different answers, different questions, we're gonna say Jay is flying a kite. How about that? Boom, boom. Well, Jay is flying 2 kites. Maybe we should do it like that there. So that's on the ground. That wouldn't be flying a kite very well. All right. So I got this backwards. So we'll say the upper one is 119 feet. And the lower one is 98 feet. Obviously not drawing the scale. I don't know. It's been a while since I flew a kite. I don't know what a kite's supposed to look like. All right. The angle formed by the 2 strings is 39 degrees. To find the distance between the 2 kites. So we're trying to find that distance right there. All right. Looks like a triangle. So we will call this, I don't know. We'll call this side A. Let's keep it simple. So A squared is equal to B squared plus C squared minus 2BC cosine of big A. All right. A we don't know. But we know B squared, which is 119 squared plus 98 squared minus 2, 119, 98 cosine of 39. And that's right there. Can you see that? I think so. Yep. So, will calculator work? A squared is equal to, yeah, ooh, 1 plus 604 squared minus 2. Why I keep doing that? That's not squared. Minus 23, 324 cosine of 39. All right. So, again, do some math. 161, 7604. And this is intermediate. You know that you can just put this in. Actually, we could just put in the calculator. Minus 23324 cosine of 39. So A squared is equal to, it says in the instructions again, carry your intermediate computations to at least 4 decimal places. And then round your answer to the nearest tenth of a foot. So A squared is equal to 5638.8476. That's intermediate. And we're doing that because we're going to take the square root of both sides. Because that's squared. Square root, whoops, clear. Square root of the answer. And you end up with A being equal to 75 point nearest 10th, 1. That's the distance between the two. Is that what y'all got? Good, good, good. All right. I had another solving trig equation ones, unless y'all have something else you want me to do. Okay. Let's do this one. X is equal to 2 plus cosine of x. All right. So again, I like trig, so I like this. For us to solve this, we need everything to have one trig function going forward. All right, so this will be 2 times 1 minus cosine squared x. This is a Pythagorean identity. It's equal to 2 plus cosine x. And we did that because we need everything to be in one with one trig identity so that it can, what's that word I'm looking for? So we can factor it and do quadratic stuff to it. So distribute 2 minus 2 cosine squared x is equal to 2 plus cosine x. We're going to subtract 2 and add 2 cosine x squared x to both sides. All right, that becomes 0, which we want. Factoring only works with 0. All right, and then this side, the 2's go away, and I end up with 2 cosine squared x plus cosine x is equal to 0. I wanted that. I wanted everything on one side. Well, I put equals 0 on both of them. I shouldn't do that. Sorry. Let me slow down. All right, so 0 is equal to, I factor cosine x out of both of these. I get cosine x times 2 cosine x plus 1. All right, so I have something times something equals 0. Something times something equals 0. That means that either cosine x is equal to 0 or 2 cosine x plus 1 is equal to 0. Cosine x is equal to 0 at pi over 2 and 3 pi over 2. For this one, got to do a little bit of algebra. 2 cosine x is equal to negative 1 cosine x is equal to negative 1/2. On our unit circle, cosine x is equal to negative 1/2 at 2 pi over 3 and at 3 and at 4 pi over 3. So the answers are, they said 0 to 2 pi. So that means all of these. We have pi over 2, 2 pi over 3, 4 pi over 3, 3 pi over 2. When I do the answer, I like to put them in order. All right. Let's do another one. So let's see, what is it? 40 minutes? Yeah. I guess we're all right. All right. So basically, you have, this is number, okay. You have her on one side of the river. This guy, let's get him a hat. Right. There are 130 meters between them. It's amazing how whiteboards drawing is never this clear. And on this side is, never mind. House is real good till y'all start looking. All right. So this is 49 degrees. This is 65 degrees. All right. So Yolanda and Michael are standing on a riverbank, 130 meters apart at points A and B. Guess we're gonna call this guy right here. See there. They want to know the distance from Michael to the house located across the river at point C. Yolanda measures angle A, which is BAC, to be 49. Michael measures angle B to be 65 degrees. We have that down. What's the distance from Michael to the house? Round your answers to the nearest tenth of a meter. All right, so let's see. Yeah, we only have one side. To use law of cosine, you need two sides. So we're going to use law of sines. I mean, I plan on using it anyway, but really we're justifying using it now. So we're trying to find little a. Whoops. So can y'all see that? Yeah. So sine of, we're trying to find little a. So little a over sine of big A is equal to little c over sine of big C. Okay. But we don't know big C. Yes, we do. Because 49 plus 65 is 114, which means the angle C is 66 degrees. All right. So now we have all three sides, all three angles, one side, we're in business. So little a over sine of 49 degrees is equal to 130 over sine of 66 degrees. Multiply by this sine of 49 on both sides, and you get little a is equal to 130 sine of 49 degrees over sine of 66 degrees. All right, so they ask us to round to the nearest tenth. This is definitely a calculator problem. If you're using our standard calculator, I call the Schoolhouse Special, there's a way to do fractions on it. If you're curious, let me know and we can look at that. Boom. And I get, round to the nearest tenth, so I get 107.4. This problem's kind of the same thing. Side. Yeah, it's kind of the same. This other one's kind of the same thing. I'm looking at problem number 11, and it's showing a figure, and it talks about a tree leaning at a particular angle to the ground, and all. You know what? Why not? Let's be thorough. Stop being lazy. 11. I know it don't make a difference. Boom. Tree. All right, so it's 62 feet tall. All right, and this angle right here is 86 degrees, and her angle is 45 degrees. All right, and they want to know how far is it from the base of the tree. All right, the angle, blah, blah, blah. Kiko, 45 degrees, 62 degrees, blah, 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 from Kiko to the base of the tree. So if you look, I have an angle, I have a side across from an angle. Law of sines. So, but this, we don't have the angle up here, but it's easy enough to get. 45 and 86, look, not 45 and 8, 45 and 86. That's 131. I mean, this angle up here is 49 degrees. And now we're in business. We're trying to find that. So x over sine of 49 degrees is equal to 62 over sine of 45 degrees, which we know sine of 45 degrees. A little bit of algebra. X is equal to 62 sine of 49 degrees over sine of 45 degrees. 62 sine of 49 over sine of 45. 66 point nearest tenth 2 feet. Oh, all right. Question for number 13. Let's see what we're looking at. The brightness of some stars can fluctuate. How much space am I going to need here? I think I can do it. All right, the brightness of some stars can fluctuate over time. Suppose the brightness of a certain star can be modeled by the following. B of t is equal to 7.9 plus 10.9 sine of 2 pi over 65t. All right, in this equation, B of t is the magnitude and t is the time in days. Suppose we start at t is equal to 0 days. Cool. In the first 65 days, when will the star's magnitude be 15? Do not round any intermediate computations. Your answers to the nearest day. So it's likely to be more than 1 day. Just as kind of a side note, the period, because it's sine, is equal to 2 pi over 65. Right? Which basically simplifies to, boom, 65. Period of 65. So you want to know within one full cycle how many answers you should get. Okay, because we know that we're saying sine is equal to a certain number. Sine is equal to a certain number. We know that there are 2 answers. So let's find them.